So this is algebra and we're doing 5.5. It's the last section for chapter 5. Write equations of parallel and perpendicular lines. So far you've been working with different ways of writing linear equations. So today you're going to write equations of parallel and perpendicular lines. So let's try the warm-up. It's always good to try the warm-up. So pause a minute and do it. Okay, this was a good warm-up to do, so hopefully you take a moment to do it. In order to decide if lines are parallel, you have to check the slope, which means you have to put it into y equals mx plus b form. So this one, it wasn't in there, so I added 2 to both sides, and I wrote it like this. It doesn't matter if you put the 2 in the front, it really doesn't matter. So y equals 2x plus 2. This one, I had to subtract 2x, so I got y equals negative 2x plus 7. The slopes are different, so they're not parallel. This one was a little bit more work. I ended up to get y by itself and put it into y equals mx plus b. I decided to subtract 4 here, and I get y equals negative x minus 4. Here, I subtracted 3x first, and I got this right here. Subtracted 3x first, and then I divided everything by 3. And I got this equation here, y equals negative x plus 5/3. And you notice that the slopes are the same, so they are parallel. This one gave you two equations to work with, and you just had to plug 4 into both of them. Find the cost at both clubs. Wait, this is 77. I made a mistake there, sorry. That's 77. 77. So it's really actually only a $6 difference. Sorry about that. All right? Okay, so this is the new stuff here. If two non-vertical lines in the same plane have the same slope, they are parallel. We kind of looked at that already. As long as you check the slope and the slope is the same, then they're parallel. Remember, you can only recognize slope in slope-intercept or in point-slope form. You cannot recognize slope in standard form. You have to put it into one of these or one of these. Okay. If two non-vertical lines are in the same plane and they have the same, let's read that again. If two non-vertical lines in the same plane have slopes that are negative reciprocals, then the lines are perpendicular. And you say, what? What's a negative reciprocal? Well, let's say you have this number, 1/2. The negative reciprocal just means that you flip it and make the sign negative. So that would actually be negative 2. Okay, let's do another one. Let's say you had, I don't know, 3/5. The negative reciprocal would be negative 5/3. Let's say you started with negative 4, and you had to find the negative reciprocal of that. You place it over 1, flip it, and make it positive. So the negative reciprocal of negative 4 is positive 1/4. Okay, so that's what negative reciprocal means. All right, let's practice some of these concepts. This is the first thing you're going to have to do. Write an equation of a line that passes through the given point and is parallel to the given line. Okay, so here's the original line. Here's the point on the parallel line. That's what this is saying here. It passes through the given point and is parallel to the given line. So what you need is you need m of the new line. If it's parallel, it has the same slope. This means parallel when you see lines like that. So this slope is negative 1. That means my new slope is also negative 1. Then you plug the point and the slope into the point-slope form. So here's point-slope form. I'm going to plug the slope and this point into this. So it's y minus 11 equals negative 1 times x minus a negative 2, which makes it a plus 2. And then I'm just going to move it into y equals mx plus b. Just tends to be the general standard form. So I'm going to distribute negative 1x minus 2. I got to get y by itself, so I'm going to add 11 to both sides. Y equals negative 1x plus 9. So this line right here is parallel to that line. The only thing that's different, you notice they have the same slopes, but they have different y-intercepts, which kind of would make sense if you think about the graph. Okay? All right, let's do another one. So if it's parallel, the new slope is going to be the same as the original slope, which is negative 2. Now I'm going to plug this point into point slope form. So it's y minus 3 equals negative 2 times x minus a negative 3, which is plus 3. Okay, distribute the negative 2. Add 3 to both sides. And I get negative 2x minus 3. So let's just double check. Same slope, different y-intercept. Perfect. They're parallel. Okay? How are parallel lines different? Well, the only thing that's different about them is that they have different y-intercepts. Or different b's, if you want to say. Okay? That's the b in y equals mx plus b. If two lines have different y-intercepts, are they parallel? Yes, but only if their slopes are the same. Only if their slopes are the same. Okay, determine which lines, this is another kind of problem you're going to get. Determine which lines, if any, are parallel or perpendicular. So what you have to do when you're asked this question is you have to find the slope of each line and then compare the slopes. So I would put them all into y equals mx plus b form so you can recognize the slope. So first of all, that means getting y by itself. So I've got to take this equation apart, and the first thing I'll do is I'll move this chunk of 2x, minus 2x, minus 2x. That makes that go away. I have 6y equals, I'm going to write the negative 2x first, minus 3. Then I got to divide everything by 6. And y equals, if I reduce this fraction right here, I get negative 1/3 x minus, this is half. 3 is half of 6, minus 1/2. Okay, so my slope here is negative 1/3. Okay, so that's line A. Let's do this one. Oh, look, it's already in slope-intercept form. So the slope is right here, and for line B, m is equal to 3. All right, this one we got to move around. We got to get y by itself to get it into y equals mx plus b so we can recognize the slope. So I'm going to move this chunk, minus 4.5x minus 4.5x. This goes away. I still have negative 1.5y equals negative 4.5x plus 6, because that's a positive 6. Then I divide everything by negative 1.5 to get y by itself. And y is equal to, if you did this on a calculator, it's 3x minus 4, or plus a negative 4. Okay, so the slope here is 3. So for line C, m equals 3. All right, let's compare these. What I can say is I can say line A and B, I'm going to say A and B are perpendicular because these are negative reciprocals of each other. A and B are perpendicular. Look at A and C are also perpendicular because their slopes are negative reciprocals of each other. So A and C are perpendicular. The last thing I can say then are that B and C are parallel. That stands for parallel. Okay? You can also write the word out too. Doesn't matter. There we go. All right, so that's the second kind of problem you're going to have. The third kind of problem is line A perpendicular to line B? Justify your answer using slopes. So this tells me I got to find the slope. And probably putting it into y equals mx plus b would be the best, so I can recognize the slope. So that means I got to get y by itself. So the first thing I'm going to do is subtract x. Goes away here. I still have 2y. I'm going to write it with my x first, so it's negative x minus 12, or plus or negative 12, it doesn't matter. Divide by 2, divide by 2, divide by 2. Okay, y equals. Now let's look at this. Remember here, this means negative 1x, doesn't it? So I could actually write this piece as the fraction negative 1/2 x minus 12 divided by 2 is 6. So my slope here is negative 1/2, right there. That's what I need to know whether they're perpendicular. So this is line A. Okay, let's move this one. We're close. All we have to do here is divide by 2. Y equals 3 over 2. I can just write that as a fraction with the x next to it, minus 4. Now, line B, my slope is 3/2. Are these related to each other in any way? No, they're not the same, and they're not negative reciprocals. So it's not perpendicular because the slopes are not negative reciprocals of each other. Okay? I hope you all know this means perpendicular. All right, the last kind of thing you're going to have to do is write an equation of the line that passes through the given point and is perpendicular to the given line. So you might remember, this is the same direction as here. Here you were checking for parallel. Here we're checking for perpendicular. So this was my original line, and this is a point on the new line. So I need to find the new perpendicular slope. Looking at this right here, the slope is 2. If the new line is perpendicular, the new slope will be negative 1/2. You flip it and make it negative. The new perpendicular slope would be negative 1/2. Okay, then I can plug this and my point into point slope form. Y minus 3 equals negative 1/2 x minus 4. I'm going to distribute that 1/2, negative 1/2 x. It might make more sense if we change this to plus a negative. I'm going to put the plus sign, and then I'm going to take half of 4, which is 2. Negative times negative is positive. And then I add 3 to both sides, and I get this, negative 1/2 x plus 5. Okay? So here we go. Let's just double check. This is my answer. I have to make sure that the slopes are negative reciprocals of each other, and they are, so that means these are perpendicular. You don't really look at the intercepts at all for perpendicular. Okay? I don't think we need to do the last one. I'll just do the new slope. The new perpendicular slope to this original line would be positive 1/4. And then this is your x1, y1. So you would plug it into point slope, move it around, and you would get this. And if you feel like you want more practice, try this part. Try plugging it into point slope and moving it around and see if you end up with this. Okay? That's all.